0.49. I have the equation for you if you'd like it.
Yeah, let me write that down. Okay, go ahead.
Cosine A was given as -8/17, and the range of cosine A was from pi is less than A is less than 3 pi over 2. Cosine B is given as a -3/5, and the range is pi is less than B, which is less than 3 pi over 2.
Okay, and this is what chapter and number?
10.2, number 49.
Okay. Okay, so by the way, when you read these, you say A is between pi and 3 pi over 2. You don't read it as pi less than A less than that. Yeah.
Okay.
So you say A is between these two values. Okay.
All right.
All right. So what is the question? What do they want us to find?
So when I was my question is the last two part of this. It's like A through F, right? And E and F they were asking for quadrant A plus B, a quadrant of A plus B, and F they were asking for quadrant of A minus B. So
Okay.
in parts A through D, right, when I solved it out, right, I got a sine of A plus B is positive in terms of the signs.
Okay.
Sine of A minus B is positive. Tangent of A plus B is negative, and tangent of A minus B is positive. And I got correct answers for all of those.
Okay. Hold on. Sine of A minus B is what?
Positive.
Okay.
Tangent of A plus B is negative.
Mm-hmm.
And
And
then
what's tangent of
tangent
A
of A
minus B?
minus B is positive. So this is where I got into a logical question because it wasn't making sense to me. I mean, like, yeah, I did the ASTC and I know if sine is
Mm-hmm.
positive and tangent is negative, then it's in a specific quadrant, right? But then I was looking at the original terms given to us, right? And A is between pi and 3 pi over 2. B is between pi and 3 pi over 2. Those are both in what, quadrant 3, right?
Yes.
So if both of them are in quadrant 3, how could one of them be in quadrant 1? Give the F portion, the quadrant of A minus B. That was in quadrant 1.
Okay. So hold on. Let's look at the what is part E? Find
Uh,
quadrant.
A plus B.
All right. A plus B, and then part F would be A minus B.
Yes, sir.
Okay. And then go ahead with your question.
My question was, okay, so when I found A plus B, that's going to be sine is positive and tangent is negative. That means ASTC, that means it's in quadrant 2.
Okay.
And then when I found that for F, where sine is positive and tangent is positive, that can only happen in quadrant 1. So I saw that both the answers were outside of quadrant 3.
Mm-hmm.
And, I'm just having a hard time visualizing or just like logically reasoning it out. How, when the range of A and B were all in quadrant 3, how can these two be in any different quadrant?
Okay. So it's actually quite easy to explain this because if you look at the minimum and the maximum value, right? So since we know that quadrant 3 is in quadrant A, B is in quadrant 3. So let's look at the minimum and maximum value, right? So if the minimum value, which is pi, okay, so that's 180 degree. The maximum it could be is 270 degrees. So let's say I have two of them to be the maximum value, okay, and two of them to be minimum value. So this is 360, right? And this one is what? 540, right? Is that good? Okay. So 540. So this is 360, right? 540 is all the way over here, right? So that means that the minimum it has to be in quadrant 1. The maximum it could be has to be in quadrant 2. So now that means they're stuck in quadrant 1 or quadrant 2. There's no way that it's outside of these two ranges. And it seems like they do fall in quadrant 1 and 2. So that's correct. All right. So so let's look at what value A and B could be, right? So we can actually find out what value of A and B could be by just looking at this, okay? So since we have cosine of A is equals to negative 8 over 17, you can find out what A is by taking A cosine inverse of negative 8 over 17. Go ahead and plug that into your calculator and see what you get. Same thing for this one. Cosine inverse of negative 3 over 5. Number you give us.
Cosine inverse of negative 8 over 17 is 108 degrees and some decimal change. It's 0.07.
Okay, so let's say 108 degrees.
Mhm.
3 over 5.
Cosine inverse of negative 3 over 5 is 126.8 degrees. So 127.
Okay, 127 degrees. Okay. All right, so if you take A minus B, okay, so you take 108 minus 127, okay, so you get negative 19 degrees, right?
Yes.
Yeah, but remember that cosine is an even function, so that's the same thing as cosine of 19 degrees, okay? Let me think for a second. Okay, and then A plus B, if you add these two together, you have what, 200 and something, which could not
275.
be. Yeah, but that's outside of 180. So this is something is wrong right here. How are you getting this value here? Because
I did
cosine negative is in the second quadrant. Okay, that's fine. This one is also in second quadrant. That's fine. Okay. Okay,
is my
so
math wrong?
I'm sorry?
Was my math wrong? I just read off what was on the calculator. I did the
No, that's
cosine
fine.
inverse.
So cosine inverse is in quadrant 1 and 2. So yeah, this is okay. Let's see. So if you add them this outside, so it's quadrant 3. That's not right. Hmm. Yeah, something's wrong.
I understand when you were drawing it out when you were adding the 180 plus 180 and 270 plus 270, what the
Mm-hmm.
possible ranges are. And I think that helps me understand what the possible ranges are now. I just didn't take that extra step of adding B or adding negative B or whatever. So that drawing helps me out a lot. When I was doing the homework, though, the homework never instructed me to take the cosine inverse of the A or B values. So I'm interested on where you want to take that, but I really don't know where it's going either.
Well, the reason why I did this is to find out what exact values A plus B and A minus B is equal to.
Okay.
So here when I do the A minus B, I got cosine of 19. So that's in quadrant 1, so that's okay. When I'm doing the A plus B though, I'm getting third quadrant. So 108 and 127 right here. Oh, I know why. Okay. Okay, so these two are assuming that you are in second quadrant, which is not correct. You are actually in the third quadrant. So that's why these two are not correct. Yeah. So you
Okay.
have to reflect this to the correct quadrant. So when you're doing cosine inverse of negative 8 over 17, this 108 right here, let me demonstrate what's wrong. This 108 is actually supposed to be down here. So what you're getting here is a reference angle, but you have to reflect it down here, okay? Because we know that A is in quadrant 3. So we need to use the reference angle. So from here to here would be 108. So that means from here to here is 72 degrees. That means that from here to here, we have to add 180 degrees. So 180 plus 72, that's 15, that's 252 degrees. So that means that A is 252 degrees. We'll do the same thing for B, which is 127. So this here is A. For B, we have 127. find out the reference angle for it. So 53. So that means that this is also 53. So now we need to find out what our actual angle B is equal to. So that's 180 plus 53. So we get 233. So if I take 252 minus 233, so this is A minus B. So this here would be 9, 4, so 19 degrees, just like we did before. And then if we do 252 plus 233, let's see, that's 5, that's 8, 485. So 485, so that's one complete revolution, right? And then let's see how much extra is that. Subtract that.
125.
125, okay.
Yes, sir.
Minus 360, that's 125. So that means it's all the way over here. So that is 5, so which is in quadrant 2. Okay?
Okay.
So A plus B, I'm sorry, A minus B is 19 degrees. A plus B is 125 degrees, or 485. They're coterminals. Okay?
Thank you. I get it now.
Yeah. So anytime inverse function, you have to make sure to reflect it to the correct quadrant, because cosine inverse, remember, it only exists in the first and second quadrant. It's not going to tell you what is the actual angle is originally. It will only reflect it to the quadrant that it's in, 1 or 2.
Is
And
that
then you
only
have
for
to take
cosine
it.
inverse, or is that for any other inverse functions
This
too?
is for all of the inverse functions. So inverse sine is only in the first and fourth quadrant. Inverse tangent is only first and fourth. And then all the other reciprocal functions are similar to its reciprocal. Okay?
Thank you. I don't remember that being discussed in lecture at all. Maybe my memory is failing me. Can you give me a chapter to reference to? Was that in chapter 9 or chapter 10, sir?
For the inverse,
Yeah, for the cosine inverse only being in a certain quadrants.
this is over inverse functions. Let's see if we cover that yet.
I can go to the syllabus really quickly too.
Yeah, I don't. I want to say that's later on, but you don't actually need to know that to answer the question that you had.
Sure, sure.
Let's see. Oh, that's next section, 10.4. So we'll learn that on Thursday.
All right, cool. Thank you.
Yeah. Okay. All right. So to continue with this identities, we're going to learn more identities. So I want you guys to start. I think you did this last time, but start with sine of a plus a using the sum and difference formula. Also do the same thing for cosine of a plus a and tangent of a plus a. Go ahead. Use the sum and difference formula. I'll be right back. All right, how are we doing? You got it? You need more time?
I think I got all three.
Okay, let's go. Great. All right, so sine A plus A. So the formula is sine A cosine A plus cosine A sine A. Well, since they're the same thing by the commutative property, we have 2 sine A cosine A. For cosine, A plus A is cosine cosine minus sine sine. All right, so since they're the same thing, we have cosine square minus sine square. For tangent, we have tangent A plus tangent A over 1 minus tangent A times tangent A. So we get 2 tangent A over 1 minus tan square A. All right, so these are 3 new formulas. They're called double angle formula that you will have to add to your list to memorize. Now, there are more formulas for tangent A and cosine. So let's do the following. Say, let's substitute cosine square A for 1 minus sine square A and see what you get.
Hey, Professor, really quickly, are these called double angle formula, or are they also
Yes.
identities?
Double angle identities. Identities means that they are always true.
Thank you, sir.
All right, so now we have 1 minus sine square A minus sine square A, which means we'll get 1 minus 2 sine square A. So that's another form of the double angle identity for cosine. So we can do the same thing, and let's substitute sine square A for 1 minus cosine square. So this time we'll have cosine square A minus 1 minus cosine square A. Distribute the negative. So we're going to have 2 of those. 2 cosine square A minus 1. So there's another one. So for cosine double angle, there are 3 different ways that you can rewrite them. For tangent, there's also 3 different ways. We're going to look at how we derive that. Okay. So you can see here, we have our double identities. Just to reiterate what I just said. So now let's look at some examples. So we are giving cosine of theta is 3/5 and sine of theta is negative. Find sine of 2 theta. Okay. So let's look. Given cosine theta is 3/5, sine theta is less than 0, find the double identity. So sine of 2 theta, cosine 2 theta, tangent of 2 theta. Okay. Now, why is it important that I need to know this? Anyone? Mai? Why do I have to know that sine theta is less than 0? Okay, Ain?
Is it so that we know that it's in a specific quadrant? So
Yeah,
if sine is negative and cosine is positive, it has to be in quadrant 4.
exactly. Okay. So we know that theta is in quadrant 4. So we're going to draw our triangle to help us determine what is the third side. So cosine here is 3/5. Okay, that's adjacent over hypotenuse. Okay. So now we can find out what is this side over here. So the y value. So that is going to be -4 because it's a 3, 4, 5 triangle. Okay. All right. So now that we know that, we can find out what is the other values that we need. So for example, sine of 2 theta is 2 sine theta cosine theta. Well, we are given cosine theta. We just have to find sine theta. So that's why we refer back to this chart, to this triangle. So sine of theta is just opposite of a hypotenuse. So -4/5. And that would give us our formula. 2 -4/5 times 3/5. So that's -24/25. Okay, similarly for cosine. Now, since cosine, there's 3 different ones, I can just use the one that's easiest, and that's the one that includes cosine because I already have cosine. So I'm going to do cosine square theta minus 1. Actually, 2. So 2 times cosine is 3/5 square minus 1. So that's 9/18/25 minus 25/25. So that is -7/25. Similarly for tangent, but since I already have sine and cosine right here, then I don't even need to use the formula. So this is just sine 2 theta over cosine 2 theta. And you can see here, both of them have a denominator of 25, which you can actually just cancel. And I'll show you that here. Okay, so you can cancel these. So you have -24/-7 or just 24/7. And of course, if you want to plug it into the formula, you get the same answer. Okay, now we're going to verify identity. So I'm going to give you guys this to work on. And we're going to do more examples of verifying identities. Okay, so these are normally the ones that people struggle with the most. So I would highly suggest you guys spend a lot of time on practicing this. Okay, go ahead. I'll probably give you another one as well if you finish that one early. Okay, so there's 2 examples there. Give you a couple minutes. I'll be right back. Raise your hand if you're done. Nobody's done? Are we stuck or?
I'm on the second verification. I'm just going low
Okay.
and slow.
All right. Raise your hand if you finished with the first one. Only one person? All right, good, good. Couple. Nicholas, you got the first one?
Not yet.
Okay. Are you stuck somewhere that I can help?
No, just take.
Hey, Professor, I have a question.
Yes, go ahead. Aim?
Oh, hey, I'm sorry, I had my microphone off. On the second verification, I know that cosine 2x can also be written as 2 cosine squared x minus 1.
Yeah.
I have a question. Do I have to distribute that 2 to that rewritten formula so it's 4
Yes.
cosine squared x minus 2?
Yes.
Okay, thank you.
So the second one is harder because now you have options. Like which one do you want to use? Okay. So the idea here is I want to be able to use it so that I can expand it to get two terms that equals cotangent and tangent. You can get lucky and just pick one and do it, and then expand and see what you get. But as you do more and more, you're going to have some kind of intuitions in order to do it. So there's more than one way to do this. So I'll give you guys a chance to try it before I show you. Soraya, how are we doing?
Oh, I just finished the first one, but I don't know what should about the second one.
Okay.
Mm-hmm.
Nicholas, how are you doing? Tariq? Tyrone? Yeah.
I'm still doing it.
You're doing number 2?
Yes.
Okay. Mohammed? Either Mohammed?
I'm on the last step on the first one.
Last step of the first one or second one?
First one.
Okay. What about you, Mai?
I just finished the first one, and I
Okay.
don't know how to do the second one.
Okay. So you have double angle, so try to expand the double angle. So for cosine, you have 3 options. Just pick the first one and try it. For sine, you only have 1 option, so go with that one. So if you're stuck on how to do number 2, go ahead and look up here. We see that we have cosine 2x and sine 2x, and we want to be able to expand it. And since the cosine have 3 different options, just try the first one and see. After trying to do the substitution, we see that the 2 will cancel. See if you can expand this into 2 fractions, and then see if you can simplify it. Okay, so I'll give you a sorry guys, that was my baby. All right, so go ahead and we're going to cancel it, and then we're going to expand this into 2 different fractions. So cosine square x over sine x cosine x minus sine square x over sine x cosine x. So now we can simplify. Since this is cosine square, we can cancel one of them with cosine here. So we are left over with cosine x over sine x. Over here we have sine square, we can cancel with one of them. Then we'll have sine x over cosine x. So this is cotangent, and this is tangent, and we're done. So again, this is not the only method of doing this. I'll show you another method, which is a little bit easier. You will see that here we have cosine over sine, right? So that actually is equals to 2 cotangent of 2x. But I haven't shown you what is the identity for cotangent, right? But you do know the reciprocal. Tan x is 1 over cotangent x, right? So that means I can take the reciprocal of cotangent, or write it as 1 over tangent of 2x. Okay, so we know that tangent of 2x is equals to 2 tangent x over 1 minus tangent square x. So now if I take the reciprocal of that, I get cotangent of 2x. 1 minus tan square x over 2 tan x. So now I'm going to make that substitution here. So the 2 came from here. 1 minus tan square x over 2 tan x. And you can see here the 2 will cancel. So I am left with 1 over tangent minus tangent square over tangent. So 1 over tangent is cotangent. One of the tangent will cancel, and we are left over with 1 tangent. So there we go. Anything, any comments, suggestion, questions? What do you guys think?
Oh, I got it now. I was stuck like on the twos. Like I didn't know what to do with the twos.
Yeah.
2 over 2. Yeah, I didn't know what to do with it, so I was stuck over there.
Yeah, just cancel. Okay.
Yeah.
All right. We're definitely gonna practice this more as we progress. Okay. So we do lots and lots of examples. All right. So let's look at A. You have to be able to identify these types of identities when you look at them. Okay. So here we see cosine square of some argument minus sine square of some argument. So this is just cosine square of x minus sine square of x, okay? And the x in this example is 7x, okay? So this cosine of 2x. So this is equals to cosine of 2 times the argument, and the argument here is 7x. So that means that we have cosine of 14x equals to these, okay? And over here, you notice that we don't have a 2 here, right? You should know that cosine of 2x is equals to 2 sine x cosine x. But since there's no 2 here, we can just divide by 2 on both sides. Okay, so now we have sine x cosine x is equals to cosine of 2x over 2. And this x right here is your 15 degree over 2. Be careful that you do not cancel this 2 right here. You cannot do that because this 2 does not belong to the argument of cosine. It's actually on the outside, so therefore you cannot cancel it. So what we have here is cosine 30 divided by 2. And cosine of 30 is what? Anybody? Square of 3 over 2 over 2. Or we can make this a fraction and multiply by 1/2. So we have square of 3 over 4. Okay. Wait, is it sine or cosine? Oh no, I messed up. This is supposed to be sine, not cosine. So all this is sine. So sine of 30 is 1/2. So in the end, you have 1/4. Or just over here. Okay, so let's do some harder ones like this. So you are given cosine 2 theta is equals to 4/5, and it's between 90 and 180. So find all 6 trig functions. Right? Is that what the question is? Yes. Oh, it's cosine? No. All right, so basically they want us to find what is sine of theta, cosine theta, tangent theta, and so forth. Okay. So now let's figure out what theta is equal to. Okay. So we can do that with the following. If cosine of 2 theta is equal to 4/5 and theta is from 90 to 180, that means that it is in quadrant 2. Okay, so let's draw our triangle here. We have it in quadrant 2. Now, since I know that cosine of 2 theta is equals to 4/5, I can find out what sine and cosine is equal to depends on which formula that I use. Now remember that the 3 formula, cosine square minus sine square, 1 minus 2 sine square, or 2 cosine square minus 1. So we have 3 of these formulas that we can pick from. You can see that the first one uses both cosine and sine. I do not want to use this one. I don't want to use this formula because it involves 2 trig functions. I want to use either this one or this one so that I can solve for sine or cosine. So let's do that. So if I have set 4/5 equals to cosine 2 theta, and now I can solve for sine. Okay, so we can subtract 1 from here. So we have negative 1/5. Divide by 2, so we have 1/10. Square root both sides, so we get plus or minus. So that means sine of theta is equals to plus or minus square root of 1/10. Okay, we can rationalize this. So we get square root of 10/10. Now, right now, it's still plus or minus. But remember, theta is in quadrant 2, and sine is positive in quadrant 2. So that means that we have positive square of 10/10, because sine theta is positive in quadrant 2. Okay? I'm positive if you guys have any questions. Hello? So we're going to do the same thing to find cosine. So I'll let you guys do that. So I know that cosine of 2 theta equals to 2 cosine square theta minus 1. So I'm going to substitute the 4/5 in because that's what it equals to. And now go ahead and solve cosine. Raise your hand when you're done. And then when you finish, find tangent. How are we doing, guys? Maya, you done? Okay, so we're going to solve for it. This time we're going to add 1. So we have 1 4/5 equals to 2 cosine square theta. Okay. Now, just remember that since I got this over here, okay, I found out that sine theta was square root of 1/10. I can use that fact in order to create this triangle here. We don't actually have to go here because that's the nice thing about this triangle here. But I'll show you both methods so you can see that they both work. All right, so here this is 9/5. Let's divide by 2 or multiply by 1/2, same thing. So we have 9/10 is equals to cosine square. Square root both sides, don't forget plus or minus. So cosine of theta is equals to square root of 9 is just 3 over 10 plus minus. Now, since we're in quadrant 2, cosine of theta is negative. So cosine of theta is negative 3 over square root of 10. We can rationalize that. Okay. So now let's see if we get the same thing by going this route. So after you find what is sine theta equal to. So sine theta is basically plus equals to positive 1 over square root of 10. Okay. So that means that opposite of it is 1. Hypotenuse is 10. So now we can find out what the x value for it is. All right. So we can say that x squared plus 1 squared equals square root of 10 squared, which is just 10 minus the 1 here. So x squared equals 9, so x is equals to 3. All right, so if you know that, then if you want to find out cosine or tangent or any other ones, we can just use this. We can just use this triangle. So let's see if we get the same thing, right? Cosine of theta is adjacent over hypotenuse. And adjacent here was 3 over, negative 3, because we're in the second quadrant. Negative 3 over square root of 10. And you can see here, we got the same thing. Okay? So you don't have to go through all of this work here after you finish this. Aim?
Professor, I'm sorry, I got lost. How did you get the y value of that triangle to be 1?
Because sine of theta was equals to plus or minus square root of 1 over 10 right here. So square root of 1 over 10 is equal to square root of 1 over square root of 10, which is 1 over square root of 10.
Okay, I see
Which
now.
is opposite over hypotenuse.
Thank you, sir.
All right, so you can do the same thing for tangent, secant, all the other stuff, okay? Let's see. Guess we can do that one. Yeah, let's do this one here, because you will see something like that. Okay, so write 3x in terms of sine x. So anytime you see anything higher, you can always use double and sum and difference formula to break it up. So here we are rewriting sine 3x as 2x plus x. So that equals 3x, right? Now we can expand this because this is like your A and this is like your B, and we are going to use this sum and difference formula. So you can see here sine, cosine, cosine, sine. This is our summation formula. And then after that, you see the sine of 2x. We can expand that using the double angle, which is this piece right here. Same thing here for cosine. And then we're basically just simplifying the rest of these by distributing. Okay, so cosine x times cosine x here is cosine square. We distribute this, we have cosine square x minus sine cube. And here they are factoring by rewriting everything in terms of sine. Okay, so you can see here in the end, we just have everything in terms of sine, because cosine square is equals to 1 minus sine square. And then we got leaving this cube here, we're just converting this cosine square using the same identity, Pythagorean identity, and then just collect like terms afterward. Okay. You will not have to memorize the product to sum identity. Just do know that it exists. We rarely use this all that much, even in calculus. So this is not really that useful right here. We're just, all we're doing here is just adding these together. It's nothing special. And the same thing for that. So what we do want to worry about is the half number identities. We use this one a lot more. Also, you don't have to memorize this as well. Okay, so we're going to derive the half number identities all from the double angle identity for cosine. So let's look how we do it. So here is the double angle identity for cosine. What we're going to do is we're going to solve for sine. And you can see here we did solve for sine x. So now what we're going to do is we're going to rewrite it so that the x is equals to a over 2. So this is where the half angle comes in. Because when you plug it into here, all we have is just a. So we see here a is just an angle, and a over 2 is half of that angle. So here we come up with the half number identities. And in order to do this for cosine, we just have to use the same double angle identity for cosine, except we use the other one, which is 2 cosine square x minus 1. We can see that over here. Okay. So if you notice that both of these here are almost exactly the same with only one difference, is that this one is minus, this one is plus. Okay. And here we have 3 different half angle identity for tangent because we can rewrite it in terms of sine, half angle of sine and cosine. And that's where you see the first one coming from. And then from here to here, they are just simplifying in order to get these two. Okay, because we normally don't use this one all that often because of that square root. But the nice thing about this one is it's only in terms of cosine, whereas this one is in terms of sine and cosine. So that's the only benefit of this first one. All right, so now we're going to look at how to find exact values of specific function. Okay, so how do you think we can do this? How do you find exact value of cosine pi over 12? Do you remember how did we find the values when we had specific angles that we want to know, like for double angle or sum and difference formula? So the special angle that we know was pi over 6, pi over 3, pi over 4, pi over 2. And we can rewrite all of these, right? So that we have common denominator. So before, when we're doing sum and difference, we can like add these two to get 7 pi over 12, or any other combination by using sum and differences. But now we're using half angle. So now we can see what we can take half of in order to get pi over 12. So here we have 2 pi over 12. So automatically we can see that right there. So that means that I can rewrite this as cosine of 2 pi over 12 divided by 2, which is the same thing as multiplying by 1/2. Right? So this is equals to pi over 12. You can see there. All right, so now my a value is 2 pi over 12 or pi over 6. Okay, so if we want to use our half angle for cosine, okay, we have what? Plus or minus 1 plus cosine A over 2. Okay, and A here is pi over 6 or 2 pi over 12. So just plug it in. All right, so cosine of pi over 6 is square 3 over 2. Now we just have to simplify this. So this is just 2 over 1, so you can take the reciprocal of this and multiply 1/2. And we get 1/2 plus square root of 3 over 4. And we can even simplify this some more by combining both of these. But I think that's probably okay. Because if we take square root of square root here, we can combine these two to get common denominator of 4. And combine these two, and then take the square root of the bottom. Question?
Yeah. How did you get the 3 over 2?
How did I get this one right here?
Yeah.
That is cosine of A. Cosine of A. And A was equals to 2 pi over 12 or pi over 6. And cosine of pi over 6 is square of 3 over 2.
Oh, okay. Yeah, I got it.
Yeah. Okay. Yeah, so it all simplified down to be plus or minus 2 square root of 2 plus square root of 3 over 2. Oh yeah, here we go. Any other questions? Not a lot of questions, huh? All right, try this one. Okay, I'm going to call on 3 of you to work on these problems. So be prepared. Okay, so for cosine of x over 2, it's mine, that's how you do it. Sine of x over 2, Muhammad Alamin. And then tangent x over 2, Muhammad Elmi. Let me know if you need help doing these. Okay. So be careful with the sign of the function as well. Y'all 3 have it or no? Hello. Just work on the side out here. Let's see. I see only AIM is in here. Did you guys get the whiteboard link? Mohammed, can you hear me? So is anybody gonna do it or what? You mean the silent treatment here?
Professor, where did you write the original problem at? I can't seem to find it on the whiteboard again.
The original problem?
Yes, sir.
It's on
The
slide 26.
slide 26. Thank you.
All right, so since nobody's doing it or even answering me, I'll just do it. Thanks, my. You guys mute. Okay, so since X is in the fourth quadrant, we can see which quadrant it will belong to if I take half of it. So let's look at the max value. So the max in quadrant 4 is 360. The min in quadrant 4 is 270. All right, if we take half of that, we have 180. And we have half of that, we have 135. So it's about right here. So that means that the angle have to be somewhere in this region right here. Okay, so that means it has to be in quadrant 2. All right, so now we need to find out what's this half angle. So given that X is in quadrant 4, so this here is X, angle X, cosine 2/3. So that's adjacent over hypotenuse. That means we can find out this side right here is equals to 3 squared minus 2 squared, square root. So that's that 9 minus 4, that's square root of 5. All right, so now we can find out what is the half angle. So we just use the formula cosine x over 2 equals to plus or minus square root 1 plus cosine x over 2. Okay, so we already have cosine x, so plug it in. Okay, and we just have to simplify this. Now, since I know that the half angle is in quadrant 2, that means that my answer needs to be negative. You see why they put a plus or minus here? Well, you have to identify what is the quadrant that the half angle is in order to determine what is the correct signs. Okay, so if I add these together, I get 1 2/3 over 2, or 5/3 times 1/2 So negative square root of 5 over 6. And of course, I can rationalize that. Okay. It's the same thing for sine. The only thing that's different is you have to subtract. So this one right here would be subtract instead. Okay. All right. So let's see what we got here. Cosine
Professor,
here.
wait, you also asked for the tangent portion. So how's the half angle identity for tangent different than sine and cosine?
Say that again.
You also asked for the tangent of x over 2, right? So I know that you told us that for cosine it's plus or minus square root of 1 plus cosine a over 2, and then for sine you switch the sign, so it's square root of 1 minus cosine a over 2. What's the difference for the tangent identities there?
Well, the tangent identity, you have 3 of them, as we pointed out up here. Now, if you already have sine and cosine, you don't have to do any of these formula. You can just put sine over cosine.
Oh, okay.
Yeah. And then, of course, the plus or minus will still depends on what quadrant you're in. And since you're in quadrant 2 for this example, it will be negative. So that's what they did here. So you can see here we did, this is what the one we did first. We did 1 plus 2/3, and then you just have to change it to a minus to do the sign. And then once you have these two, you can put sine over cosine. And of course, you can cancel the denominator because they're the same. So we just have square root of 6 over square root of 30. Simplify that and rationalize it. You get negative square root of 5 over 5. And it makes sense because it's in quadrant 2, so tan is negative, cosine is negative, sine is positive. Okay? Okay. They asked us to simplify here. Now, of course, you just have to be careful about recognizing these. So here, this is plus, so it's going to be half angle of cosine, a over 2. Now, this number right here is equals to a, right? So a is 12x over 2. So the 12 can cancel with the 2. That gives me cosine of 6x. Okay, there you go. So this is why it's important for you to memorize these formulas so that you can recognize it. Because if you don't recognize it, you're not going to know where to go. Okay. And here we have tangent. And the a here was 5 alpha. So just plug in 5 alpha divided by 2. Okay, so I think we need to practice more identities, proving for identities. So are we going to participate? If not, let me call it a day.
I'm game.
Mohammed, can you say something? Terry,
Yes, we're going to participate.
let's do some practice.
Yeah.
Okay. All right, why don't you pick one of the problem here? Let me show you the screen. All right, pick one of those, whatever you're comfortable with doing. I believe the ones that are above here, so the smaller number will probably be easier. The harder ones are at the end. So pick whatever comfort level you're good with and try it. And then if you want me to show you how to do it or check to see if you did it right, just work on the whiteboard and then I'll look at your work. Okay?
Okay.
Tyrone, you here?
Yes, I'm here.
Great. Can you write in the chat what number you guys are doing? Just pick a problem and then type in the chat what number you're doing. Tyrone, what number are you doing? Thank you. Mai? Mohammed, are you guys here? Okay, thank you. Raise your hand when you're done.
Hey, Professor, I have a question.
Yes.
So on number 61, right, I tried to use the half angle identity for secant squared, and secant squared is just 1 over cosine squared. So I thought the half angle identity would be plus minus square root of 1 plus cosine A over 2 squared. Am I going in the right direction there?
Hold on, give me a second. I'm trying to see here. So I'll say that again. What number?
61.
61 secant. Okay. Okay. Secant is 1 over cosine. Yeah.
Uh-huh. And then I just substituted the half angle identity in the denominator, and then I squared that to be consistent with cosine squared.
Uh-huh. Yeah, you can
Okay.
just flip it. You can just flip the fraction. You don't actually have to put it 1 over. That's the same thing, just easier.
Okay, so I just flip it to be 1 plus cosine A over 2. What do you, I'm sorry, I'm lost there.
Yes,
What do you mean flip it?
that's right. Hmm.
Okay.
So that's a one-step problem, right? After that, you're done.
So I'm so sorry. I know you said that was a one-step problem, but I feel like I'm just making a mountain out of a molehill. I'm not sure when I was done. Yeah.
Well,
So I mean, I
after you
feel like,
flip it,
okay, go
then you
ahead, please.
just square it, and then that's it. It's one step, literally one-step problem. No? Okay, let's go to the whiteboard. Okay, so your problem was secant square x over 2, okay? And you want to prove that it is equals to 1 plus cosine x. Okay, so you know that cosine x over 2 is equals plus or minus square root 1 plus cosine x over 2. Well, I told you to take the reciprocal of it, so secant of x over 2 is plus or minus square root of 2 over 1 plus cosine x, right? If you square both sides, then you get secant square x over 2. The square root go away. So 1 plus cosine x. So that's the other side. Right?
Okay, I see it now. Thank you.
Mm-hmm.
Hi, Professor.
Yes.
Can you do 65, please?
You see 65?
Yeah.
Okay, give me a second. I'm gonna try to work on it.
Okay.
I also need help on my question.
Okay, sure. Okay, let's see. So what have you tried on 65? Let's look at the whiteboard over here. So let's write down the problem. We have the tangent x plus cotangent x equals to 2 cosecant 2x, right? What have you tried so far?
I did the cosecant. I put two
Uh-huh.
two inverse of sine, two sine inverse,
Mm-hmm.
2x.
So 1 over
Yeah.
sine 2x, yeah? So
And
what do you
then
get here? So what is the double angle for 2x?
sine x, cosine x.
Uh-huh, that's good. Okay. So let's pause here, right? So the two can cancel. So you have 1 over sine x cosine x. Okay. So let's
Yeah.
pause right there. So let's see what we can do on the right side. So over here, there's one term, right?
Yeah.
Over here, there's two terms. So it's always easier to go from two term to one term than one term to two term. So let's see what we can do over here. So on this left-hand side, convert everything to sine cosine. All right. And then now we can combine both of them into one term. See how it's much easier to combine it so that we have one term, right? So
Yeah.
we need sine and we need cosine over here. So here we have sine square plus cosine square over sine x cosine x. So now you can see this equals to 1 over sine x cosine x. So now you can continue to go from here. So just go backward, okay? So now here you can convert this 1 to sine square plus cosine square over sine x cosine x. Then you break it into 2 to get this, and then you end up with 10x cosine x. Okay?
Oh, okay.
Yeah. All right. Who else needed? Anyone else?
Yeah, I needed help, but I don't remember the number of my question. But I did wrote down.
Look at the chat. Oh, you didn't write it out, did you?
Yeah, I did not write down the number.
All right. Let me see if I can find it. Hold on. All right, tell me your problem. Read to me your problem.
Okay, my problem is cosine 2 theta equal 2 minus
Secant square theta.
secant
Okay.
squared theta over
Okay, your
secant
number is
squared theta.
63. Okay. All right.
And what I did is
Hold on, let me write it down first. So number 63 cosine 2 theta 2 minus secant square theta over secant square theta. Okay, go ahead, tell me what you did.
I did 2 over secant squared theta negative minus secant squared theta over secant squared theta.
Okay, good. So this
Then
simplify down. Go ahead.
then what I did was since cosine is 1 over secant,
Yeah.
secant square, hold on, cosine squared would be 1 over secant squared theta. So I replaced secant with cosine, so 2 over secant squared came down to 2 cosine squared, and I simplified, and on the other side I just found minus 1.
Mm-hmm. Now what?
That's when I'm stuck.
That's the identity.
Yeah.
That's it. You're done.
Oh, okay.
So you just have to know that 2 cosine square theta minus 1 is
Is the
equal
identity?
to cosine 2 theta. Yeah,
Oh,
that's
okay.
the identity.
Okay. Thank you.
Mm-hmm. All right, who else? Tyrone, you got yours? Mai, you got yours? Hello. Okay, so I'm going to go back to the Pearson, so you guys can pick another example.
Professor,
Yes.
in preparation for the test, can you find an example that is an application of this in a word problem?
Oh yeah, we can do that next. I'm pretty sure down here, right there, there's one right there, there's one right there. All of these right here. There's a bunch of them, so yeah. We can do one of these next. If that's,
Awesome,
yeah,
that looks great.
yeah, we can do this one right here. All right, just I want you to do one more of the identity, and then we'll do the word problem. All right, so write down in the chat, see which one you're going to do. All right, we got it yet?
Hey, Professor, I think the number that I picked it involves the sum to product identities.
Which one did you pick?
75.
Oh yeah, that's not proving identities.
Yeah, oops,
It
I'm
stops at
sorry.
74. Yeah. Does anybody want me to do another problem?
So I switched to number 73 in order to
Uh,
prove something. And
yeah.
I'm stuck in expanding the left side, the sine 4 alpha. I know that sine 4 alpha can be expanded as sine 2 alpha plus 2 alpha and use
Yeah.
the double angle identity there. So that gives
Good idea.
me 2 sine alpha cosine alpha plus 2 sine alpha cosine alpha.
Mm-hmm. That's a
And
good
then
idea.
but when I add that, right, like I'm not sure how to find on the right hand side, I don't know where to find the cosine 2 alpha.
Okay, let's see. Okay, so I'll switch to the whiteboard so you guys can see. All right, so you had a good idea of converting it. So here we do 2 sine 2x cosine 2x. So that's just using double angle identity. All right. So now we can expand a little bit further, this right here. So we're using double angle identity again. So 2 times 2 sine x cosine x cosine 2x. Okay. So then we get 4 sine x cosine 2x. So what I actually used was the double angle identity where a is 2x. So sine 2 times 2x instead of using the sine 2x plus 2x. The reason why I didn't do this is because you have, in order to expand this, you have sine, cosine, cosine, sine, and that means you're going to have two terms. So that's why. Okay? Does that make sense? If I do this, I only have one term.
Yes, I see it now. Thank you.
Okay. Anyone else? Tyrone, Tarek, or Nicholas?
Yeah, 74.
74. Okay. So 74 sine 2x. All right, tell me what you've tried so far.
Yeah. On sine 2x, I put 2 sine x cosine x.
Okay.
Over sine x squared minus cosine x squared.
Over what?
Over sine x squared minus cosine x squared.
Y. So on the denominator, you just have sine x. So you can cancel stuff here. You can cancel the 2, and you can cancel the sine. Is that okay?
Yeah.
Okay. So now what you have is cosine x, right?
Yeah.
Okay. So note that the double angle identity cosine 2x is equals to cosine square x minus sine square x, right? But if you are dividing it by 2, notice this. If you let x be x over 2, okay, or let a equals x over 2, that means you can replace this x with x over 2, and you're going to have cosine x is equals to cosine square x over 2 minus sine square x over 2. So this is a form of the half angle identity where the expansion gets the half angle and the cosine here is the just x by itself. Do you see that?
Oh yeah. I
Yeah.
can see it. Thank you.
Anything else? Tyrone, do you have a problem you want me to do? Okay,
69,
so if
please.
Mohammed, yeah.
69.
All right, 69. All right, for number 69, we got cosine 2x equals 1 minus 10 square, 1 plus tangent square. All right, tell me what you've done or try. Mohammed?
I replace tangent with sine squared over cosine square. On top should be 1 minus sine squared over cosine square.
Okay, so I don't suggest that, okay, because here you have a fraction over a fraction, so which will make this more complicated. Okay, so what I think you should try is maybe expand this first and see where you can go, and then work with this and see if you can meet somewhere in the middle. Okay, you want to try that?
Okay.
Another thing that you should be aware of is this is actually an identity. What is it equal to? 1 plus tangent square x. That's a Pythagorean theorem identity. What is that equal to?
Cosine 2.
Not cosine. secant square.
Oh, my bad.
Okay. So actually that helps a lot because now over here we only have one term, right? Now, of course, we can split this into two terms, but over here I can also split it into two terms. So let's see what happened. Now here, since I'm able to rewrite it, now I can expand this into two terms. Okay, so this here would be cosine square. Tangent square is sine over cosine multiplied by the reciprocal of this, but secant is equals to 1 over cosine. And so we're dividing by 1 over cosine. So you can see here the cosine square cancel. So we just have sine square. But do you see that this is actually just the double angle identity for cosine? So there we go. That's it.
Oh, thank you.
You're welcome. Anything else? Okay, so if no more questions, we're going to go to the word problem and then we'll call it a day. Okay, so let's do 85. In the United States, circular railroads curves are designated by their degree of curvature, which is the central angle intended by a chord of 100 feet. So use the figure to write an expression for cosine of theta over 2. Okay. So we know that this chord right here is going to be 100. Well, if you divide that in half, it will be 50. So this angle right here would be theta over 2. Let's see. So we can use the value for cosine of theta over 2, and we can see that we have a right triangle right here. Okay, so if I have a right triangle, that means I can use the Pythagorean theorem identity, and we can figure out what is the r is equal to. I think that's in the second value, right? Okay. All right, so I'll give you a second to try it, and then we'll go over it.
Hey, Professor, I don't understand why you mentioned that there is a right angle in order to use a trigonometric function.
Okay, so I mentioned that there's a right angle because we are going to use that fact in order to link all these variables together. So cosine is adjacent over what?
So adjacent over hypotenuse.
Hypotenuse, right? So if the angle is theta over 2 here, what is adjacent and what is hypotenuse?
If the angle is theta over 2 here. Okay, so the adjacent would be the striped line, right? And then the
Yes.
hypotenuse would be r in this case.
Yes, exactly. So can you find a notation for the stripe line?
Would the striped line be r minus b?
Exactly. That's it. So you should be able to find out the ratio for cosine of theta over 2.
Okay, I think I see it. Thank you.
And I'm ready to.
Do you need help on the third one?
I'm so on this part B, right? It's asking for tangent of theta over 4.
Mm-hmm. Yeah, and?
It's not as easy as taking sine of theta over 2 over cosine of theta over 2, is it?
No, you can't do that. All right, so let's go back to the whiteboard. Okay, so part B asks us to use the result of part A and the third half number identity for tangent to write an expression for theta over 4. Tangent of theta over 4. All right, so let's look. Tangent of theta over 2 divided by 2. So this means that A here is theta over 2. Okay, so this is tangent of A over 2. Does that make sense?
Yes, I see that now.
Okay, so we have 1 minus cosine of A over sine A. So A here is theta over 2, right?
Yes.
All right. So we know that cosine of theta over 2 is r minus b over r. And sine of theta over 2, well, you can easily find that, right?
It's 50
Sine
over r.
is opposite over hypotenuse. So opposite we have is 50 over r. So this is equals to 1 minus r over b over r divided by 50 over r. Now we can convert this 1 here to r over r minus r minus b over r. 50 over r. And just combine it, and then we can get rid of that r in the denominator. R minus b over r over 50 over r. So the r will cancel. This r also cancel. So I have negative b over 50. Okay. Is
Okay,
that
thank
okay?
you. Yes.
Yeah. Actually, I don't think it's negative b. It's actually positive because I need to put parenthesis here, distribute this. So that will become a positive b, so not negative b. And then if b is equal to 12, what is the measure of angle theta to the nearest degree? All right, so part C, b equals 12. So here we have, let's see, what is it in terms of tangent? So we should use tangent. Let's see, tangent of theta over 4 is equals to 12 over 50. So what we can do is use tangent inverse. 12 over 50, and then just multiply it by 4. So move this over. So theta is equals 4 times tangent inverse of 12 over 50. Go ahead and put that in the calculator and let me know what you get.
To the nearest degree, I got 53.98 degrees, so 54 degrees.
Yep, that's good. 54 degrees.
Awesome. And then I know in the slides and then in these next two pages, 761 and 762, there are questions about wattage. Is that something that we need to be aware of for our
No.
test?
No, I won't ask you about wattage.
Okay, thank you.
But something about this is good. Yeah, you're talking about this here, right? Yeah, I won't ask you something that would require extra knowledge, like this formula right here. I won't ask you that.
Okay, thank you.
When we get to vectors, we will do some physics, and that's when I'll tell you what you need to memorize, okay? When we're doing vectors. All right, that wraps up today. So have a great day, and I'll see you guys Thursday.
Thank you, Professor.
Thank you. Have a good day.
Thank you. You have a good
Thank you.
Take care.